I want to tell you about different types of solution a linear system of equations can have. The most useful one is when the system has one unique solution. So one unique solution. Okay. An example of that is, let's say that we have minus 5x plus 3y equals 11, and minus 7x minus 6y equals, let's say, 12. And so I want to solve this by, say, addition method. I'm going to multiply the first one by 2, and that gives me now minus 10x plus 6y equals 22. And the second equation, I'm going to leave it untouched, minus 7x minus 6y equals 12. Now I add them together, I get negative 17x. This cancels, equals 34. 34. So divide both sides by negative 7, and x equals 34 divided by negative 17. That gives me negative 2. Now, what is the value of y? I can use the first equation or the second equation and find the value of y. Let me use the second equation. So minus 5 times negative 2 plus 3y equals 11. I have 10 plus 3y equals 11. Okay, so 3y equals, subtract 10, I get 1, and y equals 1/3. So we do have, our solution is negative 2 and 1/3. And so that means that we have two lines that they intersected at negative 2, comma 1/3, a unique solution. Remember, two linear lines can only intersect only once. Okay, so let's now have an example of, say, infinitely many solutions. So infinitely many solutions. Suppose I have 2x minus 3y equals 1, and 6x minus 9y equals 3. So before even doing any work, I can see that the first one, if I multiply the first one by 3, I get the second one. So we're talking about the same line. But let's say that we didn't see that, let's say we didn't realize that. So we want to solve this, and let's multiply the first one by negative 3. That gives me minus 6x plus 9y equals negative 3. And then I get the second one was 6x minus 9y equals 3. Add them together. Okay, so notice that now I get 0 plus 0 equals 0. So this system has infinitely many solutions. What does that mean? That means that the graph is the same line. That means that the graphs coincide. So if you graph them separately, you can't tell the difference. The graph of both equations coincide. One is a multiple of the other. Okay, so we also call that in math, we also call that dependent. Okay. The third case scenario would be that our system has no solution whatsoever. Let's just have an example of that. Suppose I have 3x minus 2y equals 5, and minus 6x plus 4y equals 6. Okay. And so I'm going to go ahead and multiply the first one by 2, and that's going to give me 6x minus 4y equals 10. And in the denominator, second equation is unchanged, minus 6x plus 4y equals 6. Add them together, I get 0 plus 0 equals 16. So 0 equals 16. How could that be? So this one has no solution. We also, in math, we know this system as inconsistent. Let me write it here. Inconsistent. Or some textbook also show that as an empty set. So this one has no solution. I like the inconsistent better myself, but it is up to you. So if you are like me and you're thinking that, what the heck does this mean? I certainly have a linear line in here, and I have another, linear line in here. What does it mean? Does it mean that they're inconsistent or they have no solution? That means that the graph of them never intersect. What does that mean? They are parallel. They never intersect each other. That's what it means. Okay, I'll talk to you soon.